Software development process models. So here we're going to be talking about various kinds of software development processes, but let's note that all of them have a general kind of life cycle. So all programs, all program developments go through the same steps. And it's just a matter of how we go through the steps and their different approaches, and that's what we're going to be discussing here. So first, there is a conception of a program, a conception of a problem, a conception of a set of functions. For example, you may need to get some data from the internet and calculate some averages to present a report of how many times a site was visited in a day. And you can get some data analytics from site visits. When do people visit the site? What time do they visit? How many people visited the site at a particular time? Is there different days that they visit? How long do people spend on your website? You can calculate all that with information that is just already inherent in the website infrastructure, right? So first is a conception. What is your system, your program is going to do? Is it going to analyze data? Is it going to get data? Has to be something, of course, digital and at the software level, as we're discussing. And then you will go to requirements gathering. After conception, we kind of got that requirements gathering. So this is understanding the specificity of the features and the functions that the computer can and must produce. And there will be exploration, there'll be discussions with people, conversations, and modeling, and we'll talk about this as well. So we got that. Designer wants to start designing the actual parts of the system, and the design can be a visual design, or it can be part, and actually has to be both. It will be part of the code, but usually when we're talking about the design, we're talking about more of the user interface and a more general set of components or stories that the code will implement. And then the code and debugging will actually write out the program in programming languages like Python or C++ or Java, as you may have heard. Testing, and then of course we need to test the program to see if the features, the functions work, and then it may arrive at some state where you feel comfortable in releasing for it to get used, and then of course hopefully address that initial idea that you had. And then there's the maintenance. Things change, other systems change, data changes, new information comes in, things break. So you need to maintain, and you can't expect that if you just release something, it's just going to stay functioning forever. And then potentially retirement, getting rid of it, decommissioning, removing it from the internet, and so on. So that's the basic steps that all program development goes through. Some main fourth variables of software development projects we should be attentive to. So cost. Cost is, everything is about cost in a way, right? How much it costs to do something. It will influence the size of a team and types of tools available and the functions that can actually be created, the type of program that can be created, the time delivery schedule imposed from outside. So how much time things need to be done by. Time is a kind of cost, and time is everything. Quality, number and severity of defects you're willing to release with. So understanding what your quality requirements are and how good or acceptable you are to lack of particular features or the lack of feature qualities. And then of course the features themselves. And here maybe also we can think of this as kind of complexity. So the complexity of the features and how many they are and how difficult they are to implement. And this will seriously impact the software development project. So cost, time, quality, and features or feature complexity. Now let's actually talk about these process models. So first, let's talk about one that is a kind of model but without sort of much structure. So in this code and fix way to approach it, code and fix, you just write the code and fix it as you go. In other words, there's no formal requirement, there's no required documentation, there's no initial discussion of what the user wants to see, what the user inputs are. There's no quality assurance or testing. Mostly what happens in an intro to programming course. Now, of course, you do have no formal requirements, but you have to know what's something. There has to be some concept of what you want to do. Do you want to take a number and calculate it? You know, you need to create a report on some data. What do you need to do? But then you kind of just go and start writing some code. Code and fix is a terrific way to do quick and dirty prototypes and short one-off programs. It's useful to validate architectural decisions and to show a quick version of a user interface design, use it to understand the larger problem you're working on. So in other words, it's you got some conceptual development and then you just code, you could just start writing the code in Python or whatever language you're using. And then of course, prayer is optional, may help. We're not sure yet. Uh, and then you can release the product. But usually, I think code and fix, you're not really releasing. You're releasing maybe internally, or you're releasing for some tests. You can't create complex software programs with a just code and fix approach. That's why we have these more developed, sophisticated models. And the traditional one, let's say it's called the waterfall model, and there's a progression through each phase in order. It requires detailed documentation at each phase, requires reviews and sign off at each stage, assembly line kind of mentality, and it's not really used uh, that much, I think, but it is still used in many organizations. Um, Conceptual, so always conceptual development, and then requirements analysis, then architectural design, more detailed design, code and debug, system testing, release, and maintenance. So there's essentially the list that we talked about before that all life cycle of software development requires. But in other words, the problem is that it doesn't work in practice in the sense that nothing is so linear in life. So the idea here is that you're required to finish the previous step before you move into the next step. That's how some project management requirements function. But it's problematic because sometimes it may take a long time just to fix one little problem in one stage, and then you're prohibited from moving forward and you lose a lot of time. So it's not that it doesn't work, it just doesn't work well in practice, or better, it doesn't work as good as it could work. There's no provision for moving backwards. So even though you're very detailed before you're moving forward, maybe something changes in the requirements and the client or the time or the technologies of the day, and then you have to go back to a previous step to add some requirements, but there is no sort of plan for to do that in this framework. That's why it's problematic. Now, there is the iterative approach, which is the approach that is most common in newer entrepreneurial organizations, and the approach of agile that we'll discuss more later. But essentially, you you collect. The idea is that you collect a set of requirements. Of course, this first conceptualization, but then you identify some requirements at a point in time, and then you prioritize certain requirements, but based on customer ranking or client ranking or maybe product owners ranking. You pick highest priority requirement and plan series of iterations, each iteration with a project or set of requirements. So for each iteration, you complete all next highest priority requirements. You're completing each project with a portion of requirements. So we have a conceptual idea of what the program is going to need to do, and then we have requirements. But in the iterative approach, we take out of the list of requirements, which may be many, we make a priority. We identify some, and then we take just these some to move to the next step. And then after we work on these, sort of, and then we can kind of go back, and that's the whole idea of the iteration. See how the whole process of these requirements are successful, and then go back to identify the other set of priority requirements. So that's just in general an iterative approach. And there's also something called evolutionary prototyping. So This one prioritizes requirements as they are received. So it produces succession of increasingly feature-rich versions. Each version is refined based on customer feedback and results of testing, provides improved progress visibility, works best with experienced teams, can lead to unrealistic schedules, though, budget overruns, optimistic expectations, possibility of bad design due to constant evolution. So, this is a kind of iterative approach. Here, there's a sort of image, initial concept and requirements. There's a quick design, and then there's a building a prototype, customer evaluation, update new requirements, refine design prototypes, and then back to quick design again. And then once everybody's happy, you go to final testing. So this is a kind of iterative approach, but there are specificities to it on what people call this evolutionary prototyping. So to learn more specifics, we kind of need to go into that particular philosophy. Note that all of these are sort of philosophies. They're more human concepts, and they're kind of fuzzy. They're fuzzy. They're not um, that sort of objectively um, objectively consistent as some other aspects of engineering are. So then next we will talk about agile methodologies.